Hey folks, welcome to the last part. We left off in video 4 for the Intro to Measurement Unit, just going through and figuring out these multi-step problems where we solved a couple of different steps, keeping our places with digits and whatnot. So you could go back to video 4 or 5 to learn a little bit more about significant digits. The last video that we're running through here on rearranging formulas, this is one of those ones that it seems regardless of the grade level, it always causes a little bit of stress, whether or not you can kind of catch on what to do. There's a lot of algebra, just moving things around, and I've got some hints here that might help, and we'll run through a couple of practice problems. So the first step is eliminate any fractions. If you see a fraction that's there, fractions when you're rearranging formulas are a bit of a headache. So if we can get rid of them, it makes the problem a lot easier. The second part would be to add or subtract any terms to the other side of the equal sign that do not contain the variable. So we're trying to move things over that we might be able to combine, or to get things to the right side, maybe so it has a positive sign instead of a negative sign. We're moving things around. The third step would be to divide by any coefficient in front of the variable, so any numbers that show up in front of whatever letter you're trying to solve for. And then the last part is, if it's there, is to take the root of any power on the variable itself. So if it's a square, maybe we need a square root or something like that. So let's take a look at the first example. It says solve the following equation, and we're going to try to solve this one for x. Now, like I mentioned before, the first step, this one has fractions set in it. So we're going to take both fractions, and we're going to eliminate them, to get rid of them. So the first thing I would do here, and you might find little tricks as you get more comfortable with it, I'm just going to kind of run through all of the steps to try to make it as clear as I can. So the first thing here is we're going to take this divided by x, a times y, divided by x, and I'm going to take whatever's on the bottom, whatever's in the denominator spot, and I'm going to do the opposite operation to eliminate the fraction. So I'm going to multiply by x. So multiply by x, and whatever you do to one side of the equal sign, you need to do to all of the terms across the equation. So multiply by x on the other side as well. X divided by x on the left, that's going to give me 1. So these terms effectively cancel out, and that's really the reason for doing the step. So right at what you have left, you have AY is equal to CBX over S. Now do the same step again with the fraction. We have a division by S in this case. So now I'm going to do the opposite. I'm going to multiply by S. So that's going to give me SAY on the left. And then hopefully you can see that S divided by S reduces down to 1, so it gets rid of the fraction, which is what we're aiming to do. And that gives me CBX on the right. So now I'm trying to solve this thing for x. X currently is being multiplied by C and by B. So do the opposite operation. I'm going to divide this in this step by whatever is in front of the variable I'm trying to solve for. So divide by C, divide by B. You could do those in separate steps if you like. I'm just going to do them together. Whatever I do to one side, you do to the other side. C divided by C gives you 1, B divided by B gives you 1. And so really what we're left with at the end is kind of seeing what this works out to say x is equal to SAY over CB. Now, I know x is on the right, and you're used to seeing things solved that are on the left. It's fine. All you have to do is just flip it over, and you can write the exact same thing again. For those that are curious as to why that works mathematically, as soon as you move things over, the signs change, and then you can just divide by the negative sign on each one. So they're interchangeable. Okay, so a little bit of rearranging to start with. Hopefully you've seen this one before. Equation for a straight line, solve the following equation for x. So again, give it a try on your own, and we'll just see how you do. So if I'm solving for x here, there's no fraction. I can skip that step, which means now I'm kind of in that add subtract part. The x is being multiplied by m, it's being added to b. So I'm going to do the opposite operation to get that b over to the other side. It's being added, So I'm going to subtract b. I'm going to subtract b from both sides. B's are going to cancel, and what I'm left with underneath is y minus b is equal to mx. After that, I have an m in front of the x, and I'm trying to solve for it, so I'm going to divide by whatever's in front of the x. Divide by m, divide by m. Notice everything on the left-hand side gets divided by m, not just the y. Okay, everything gets divided when you divide something over to the other side. M divided by m, that reduces down to 1. And so really I have x is equal to y minus b all over m as a rearrangement. Right, and one last one just to kind of get going. I have a vf squared is equal to vi squared plus 2ad. So this is solving for initial velocity with our big 5, which is something that we'll kind of see in the course. So vf squared is equal to vi squared plus 2ad. I need to solve for vi. Well, vi's squared and it's being added to 2ad. There's no fractions here, so we don't have to worry about that step. I do need to subtract the 2ad, which is kind of like what we did with the b term in the last question. That's going to cancel all these out, but I also need to minus 2ad on the left-hand side as well. So if I write out what this is, I've got vf squared minus 2ad is equal to vi squared. Now, the last step, there's no division here because there's nothing in front of the vi term, but there is a square that I do need to square root. So square root and square root. That's going to help me cancel out this. A square and a square root will reduce to 1. And notice everything on the left got squared. It's not the square root of vf squared minus the square root of 2ad. It's the whole expression all square rooted. So all square rooted vf squared minus 2ad is equal to vi squared. And that would be our rearranging. At this point, you're ready to try out the second worksheet, part 2, which is also on the website for you to print off and to try out. So if you have any questions, just let me know.